Hey physicists, we're looking at using kinematic equations. Sorry, I'm not here with you, or maybe you're using this as a review, but we spent all that time deriving kinematic equations, and now we're going to use them. Daniela is so pumped. There were these big three, and then we have two others that are just kind of like what acceleration is. And so I'm gonna give you one example, and then you're off to the races on your own to use them. Okay. On Squalogy, ping, there's a link that should run you to this page. This is the physics classroom. And if you scroll down a little bit, check your understanding, and there are 19 beautiful problems of kinematics. They use these equations in different orders, and so it's your job to figure out which equation to use. And so I'm going to show you one. I'm going to show you the first one. You can click the answer for the answer, and I also see the solution, but I want to walk you through one of the solutions, right? So you're going to go, I'm going to do the first one with you, and then the rest are yours, and you should be able to do all of them. So airplane accelerates down a runway at a certain acceleration for a certain time, finally lifts off the ground. Determine its distance. So I don't know, but I have these fancy equations, and there's a lot of different variables in there. So what I'm going to do is just start marking in the variables that I know. They said accelerate down the runway. Here's the acceleration. They say for a certain time. I'm going to put t there. And we're interested in distance. Sounds like x to me. Now, so I'm looking for an equation with a, t, and x involved. This has a and t, but no x involved. So I'm not going to use this one, right? This has a, t, and x. This has no t involved. So I'm not going to use that one, right? And so just looking at what I have and what I'm interested in, it looks like, wow, we're all over the map. Looks like we're going to use this one right now. I'm looking for x. This x naught lets us still use the equation if we don't start at 0, but I'm assuming the airplane starts at 0, so I'm going to choose x0 as nothing. This is v naught, right? T plus 1/2 at squared. I have the a, I have the t. The wild card right now is this v naught, but the airplane starts at rest, right? We're kind of assuming that. So some of these you might have to have a little bit of assumption. So I'm assuming v naught is 0. When we start looking at the plane before it goes, it's at 0 meters per second. All right, so let's put in 0 for this. Right? Let's put in 32.8 for that. Still 0, it doesn't matter. And so essentially this is going to be 1/2 times 3.2, that's our acceleration, times 32.8 squared. Grab a real calculator. Yes, I had one in my pocket. Don't judge me. Grab a real calculator, not your phone. That's not you're gonna get messed up with your multiplication stuff, and start multiplying. I got 1721, right? So 1721 or 1721. We're talking about meters, so let's check it. That's the whole idea, is that you're checking these. See the answer. 1720. Great. We'll talk about significant figures. You can also say, show me the solution, and see what they're doing. Oh, this is all of the solutions. You don't want to look too closely, it'll give it away. So maybe it might help you to see which equation they're using, and you can learn it in Japanese too, and then see what they put in there. It's still a little clunky, but it at least gives you a foothold. Cool. That's what you are up to. You're just trying to figure out which equation to use when. Think about what is given and pick the right equation. That's the hardest part, I think. Good luck. I want those 19 done when I see you. You can do it.